So remember, when we're looking at the relationship between two variables, even though we might have all these different methods for being able to do it, the goal is always the same, and that's to take a relationship that exists within the statistical data and describe it to people in a way that is intuitive and actually allows them to understand things about what's going on. So, here, we're going to discuss how do you look at the relationship between a categorical variable and a continuous variable. And there are plenty of examples of this, right? When you're looking at the relationship between race and test scores, when you're looking at the relationship between income and gender, when you're looking at the relationship between any variety of continuous measures ranging from counts of different resources to money to achievement, to different psychological scales, whatever it is, across some groups, right? All those things are the same. They're just the relationship between a continuous variable and a categorical variable. And how do we do this? It's actually pretty straightforward. So let's say we wanted to look at the relationship between the majors of different students in college and the number of hours per week that they spend studying, right? Well, if you wanted to know the relationship between those two things, where one is continuous and the other is categorical, we might just have a table that looks something like this. This table is called a conditional means table, and it very simply is you taking the average of the continuous variable and looking at it separately for each one of the groups of the categorical variable. So for here, the average number of hours spent studying per week for math majors is 9.7 hours. The average number of hours per week studying for bio majors is 13.1 hours, and the average number of hours studying per week for chemistry majors is 10.6 hours. And from this by itself, we've learned a lot. We've learned that on average, biology majors are studying the most, and on average, math majors are studying the least. And this by no means indicates that every bio major is studying more than every math major, right? Certainly there are distributions within the majors of how much they're studying, but at the very least, like looking at these differences in average pretty much summarizes a lot of the information you're probably wondering about when you actually ask the question, is there a relationship between the major someone is and the number of hours they spend studying? So this is called a conditional means table. Now often you'll see them displayed like this. Pretty commonly when you see a conditional means table, you'll see either next to it or underneath or somewhere like that, you'll see kind of like this standard deviations as well for each one of the groups. So in this case, the standard deviation for the math majors is 3.1, the standard deviation for the bio majors is 3.2, the standard deviation for the chemistry majors is 3.1 again. So within the groups, they tend to have roughly the same kind of spread, but there are differences in means, which are actually really useful for us, right? Now this is called a conditional means table. You can also view this graphically, and you've probably viewed something like this graphically. You can use a bar graph similar to the type that we've used before, except in this case on the y-axis you have the average for each one of the groups, and it enables you to visually kind of see the differences. Right? Now the other thing that's kind of nice about conditional means is that if there are only two groups, you can just do the subtraction to get the difference between the two. So let's take something where we were, say, looking at teacher salary, and we were trying to get the average teacher salary. And in particular, let's say we also have information for all the teachers for what gender they are. And for the purpose of the example here, let's say that there are two genders, male and female, or men and women in this particular data, right? Well, we could create a conditional means table that looks just like this, right? Where men on average are making $65,460.50. And then women on average are making $57,123.70, right? So we can see right here that men on average are making more than women in this particular data. However, because there are only two groups, you can go even one step farther and you can just see exactly how much more they are making by doing the subtraction. So if we do the salary for men and minus the salary for women, you're going to get a difference of about 8,300 or 8,300. So you are able to say that on average, men are making about $8,300 more than women in this particular sample, right? And that number, that 8,300 right there, pretty much encapsulates a lot of what you're probably asking when you ask about the relationship between gender and salary, right? We ask that question a lot, but from a statistical point of view, that can all kind of be summed up right in this number 8,300. Now, that's not to say you're not going to do further research later to, try to understand more of where that comes from or what's going on and all of that. But if you're really just trying to summarize the statistical relationship, you can do that with that 8,300. Now, of course, in the full sentence, men make about 8,300 more than women. And that's pretty much the answer to your question there. And just like it was before, you could take this information and turn it into a bar graph as well. So conditional means are a really convenient way to be able to summarize information about the relationship between a categorical variable and a continuous variable, which you can do either through the table or in a graphical form, which is just another form of a bar plot.